live right now. We'll be doing more about, we'll be continuing on what we started last week. Last week we did an API, which we used, last week we did an API and we used Spring. We started our journey here at start.spring.io. We created an application. Maven, we used a build system. You can use Gradle or you can use Maven, but we used Maven for application. We used our language. The language we used was Java. You can use Kotlin, you can use Groovy. And we, instead of using the snapshot, we used a stable version, which is this. Then we created an application, and then we started it, and the application is actually here. And let me go to where it is. Recent is called Coffee. And yeah, where is it? Oh, yeah, actually it's the one open here. This application, I was trying to do some bean stuff there, but we did this. And this is what we did last week, and this is a simple application that exposes an API on port. We have on localhost. Then our port is 8081. This is our port, and this is our data object. Our data object is what the structure of data that are to be stored in our database. We used MongoDB. You can check here. Let me see here. We used MongoDB, and yeah, MongoDB is a document database. It's a NoSQL, meaning NoSQL means not only SQL. It's a bit different with to Oracle or to Postgre or MySQL, that it doesn't have a schema. We'll be talking about schema next time. On when you're doing financial and such stuff, financial application like I usually do every day, we need a schema to ensure that we have a structured way of data, a data that is structured. But since we just want to store some data in the database today, we just use document database. There are several kinds of database you can use. There are a document database such as Mongo. You can use Couchbase, which is also a document database. You can use a column database. Column database is a bit different from document database. You can use Cassandra, but Cassandra is the best example. You can use graph database. A graph database stores data as a graph. A graph is it's a kind of algorithm that are used in computer science. You can use graph database. A good example is Neo4j or Titans. There is Titans, there is Neo4j. So today I'm going to look for my database, where it is. I don't know where my, yeah. I'm going to look for where my database is, and then I'll start running the application. So we come here and let me check where my database is, MongoDB. It searches, and then I'll start the daemon. Let me explain what we did last time. What we did last time was we created, let me start, like go back from the start. You can choose Gradle or you can choose Maven, but I chose Maven. Spring, for those who are not with us, Spring is a framework, just like any other framework. We have Spring for Java. You can have Java EE. You can have other application, other frameworks. For PHP, we have Laravel. We have CodeIgniter. For Elixir, we have Phoenix. For .NET languages such as C Sharp, we have ESP.NET. Uh, and there are quite a number of frameworks. Almost every language has its own framework. For now, we'll be using Spring. Spring is actually quite easy to start with, and that's why I chose it. And we'll be writing, we need a package to package where our data will be, and this package, we called it live last time. Then we said our application will be called coffee. We said we need some dependency. We need a dependency on HTTP library that will help us do HTTP, and we chose reactive web, which it will also give us a Netty. Netty is a reactive server. For example, before we used to use JBoss or Wordfly, then we run application against it. But right now we are running, we package the server with the application. So here we'll be using Netty. I made use of Mongo, which is reactive Mongo. This Spring Data Reactive Mongo. These are dependencies that we need. We also added Lombok. Lombok is a simple, it's a Java annotation library that helps you reduce boilerplate code. It's code that you don't need, such as creating getters and setters, doing constructors, like no argument constructor, all arguments constructor. Lombok will help us with this. That's why we add it. Then we came and what else did we add? Yeah, I think that's enough for now. And we created our application, coffee. Then we extracted it and opened it with our IDE. IDE stands for Integrated Development Environment. If you don't know what that is, it's just an editor that helps us edit our application, but it does more than basic editors do. So we have this is a package we did, com.live.coffee. Then we have our folders or packages inside the package, which are, we have controllers, we have model, we have repo, and we have main application. For every application, when you are running an application in any language, let me say not all languages, but many languages, you need what we call main function or main method. For Java, main method starts with public, static, void, then it has string, and these and arguments, these args. And because it's a Spring application, we add what we call Spring application.learn. Then it says this coffee application, and then .class. And this has to be there for a Spring application to run. So we have, if you want to run, we start it here. So we started by creating a model. A model is the structure of a data that will be stored in our database. I'll be creating another model. What we'll be doing today, because we wrote this application, I'll be writing another model for coffee orders. Our application is, we are selling coffee, so we need some observability and know, like, at this time, several people bought coffee from our shop, and I asked everyone to have their mug of coffee. I have mine with me. Actually, I'll be sipping as we go along. So we'll be doing this. This is a coffee object. An object is basically when you write a class, you are building a house. You start by structuring, making a blueprint. Then I use the blueprint to make a house, to build a house. So a class is like a blueprint for an object. And I actually demonstrated just here the other time that you can come here and you give the type of your coffee, then you give it a name. You can give it CF. Then when you do this coffee, and then you give it, like for the first one is an ID, let's say one, let's say one, ID one. Then the second name is name for, actually last time I talked about some companies that do coffee, but my friend Daniel told me I should have talked about types of coffee like mocha, cappuccino, espresso also. So let's say we have mocha, and we have mocha has quite so much milk. So let's say it's white, and yeah. So when we do this, we say we are creating an object. This is what we refer in programming as instantiation. Instantiation. We are creating an instance of a class, which is an object. We are using a keyword new. When you use keyword new, you are creating an object. This corresponds with the first ID, and because it's an integer, int means it's an integer, it has to be an integer. String is anything that is inside this double whatever. I don't remember what they're called. And white is a string, which is color, is inside that. So this is how we instantiate. So we are creating our objects that way. But you notice that if you joined me last time, we never did this. We never did this because Spring itself has a way of what you call, most framework have this, what you call dependency injection. Dependency injection is, this is a manual way of doing it, but there is a way a framework can inject our objects to what we'll be talking about. So I had said I will talk about coffee. We'll be talking about beans. Java has what we call beans, and beans are added to the application using in what we call IOC. IOC stands for inverse of control, which is a container that we add our beans. So it will add our objects when they are needed, instead of every time doing new coffee and this. So this, we are done with it. So these are coffee object. Before we leave here, we create another Java class. We call these coffee orders. Coffee orders. And coffee orders, it's a class. So we'll come here and say coffee orders has private. It's better to call private is a scope, meaning that the attributes will be giving coffee orders, they will be scoped just for this this package, this model package. Okay, so we say private, then we say it will have string what coffee, let's say date, type date, and it will be date. Let's just say date, and we have to bring in date, import class from Java util. And this I'll be talking about this shortly. This the Java standard library. So we have date, and we have what else? What do we need for to see how much of coffee you are selling? Let's say we have sold 10 mugs of mocha. So that is, let's say, the name of the coffee, private. That's the scope. Then we say string name. We can have them, we can change this and bring it up here. We have name and date. We can have ID to make it a bit simple. We have an integer and we have ID. So these are objects, and we said last time, if you are to create an object like this in most languages, you need to create a getter, getters and setters, and all arguments constructor, and no argument constructor, and some other code. But since these are data object, for example, if you do Kotlin, if you are good at Kotlin, this you write your data class as data, then you say coffee orders. And this won't specify so much about whether it has getters, setters, or it has all those. We call them boilerplate code. It doesn't have all boilerplate code. Actually, this was taken from Scala. Scala has what we call case class. A case class is exactly the same. It's a data class. It doesn't have all these, we might say ceremony. It's just an essence thing. So let's see how it would look like if you are to add all these ceremony. We do this, and then because we don't want to write stupid code, we have IDEs, editors that do that for us, and IntelliJ is one of them. So we come here and say generate. Then we say we want to generate getters and setters for both date. So we have get ID, set ID, get date, set date. And okay, let me take this back to the top. It's here. So we can see it. Then we need a constructor. We need to create all arguments constructor, which we do exactly the same. IntelliJ will do it for us. We say we want a constructor because we only have two parameters. That's all we have. We have a constructor that we use when we are creating our coffee orders object. Then we need, when writing this code, we also need a no argument constructor. So we come here and generate this. Right now we won't choose any, just like that. We won't choose any, so it won't have any arguments. And this okay, let me undo. This is how our data object will look like. And because it's Mongo, we need to specify that it's a document. So we write document to make sure that this Mongo treats as a document. This in Mongo it will be stored as a JSON object. Also, maybe you might disagree with me. They have what they call BSON, but basically a JSON. If you look at it, it looks more like a JSON. We have that object, but since we don't want to this or this ceremony, we can do away with this boilerplate code. For getters and setters, we just come here and say data. Yeah, when we do that, we don't need any getters and setters. So from here, we can erase that. This Lombok helping us do this. Lombok, actually, we can see up here, it comes from Lombok data. And we can, since we have a no argument constructor and all argument constructor, we can get rid of them, and we come and say no argument constructor and all arguments constructor, and then we erase. So this exactly the same as what we had, just simple code, just simpler than we had. Then model is our data object, how data will look like when it's stored in the database or when you are transferring it. This we are following what we call MVC. MVC, M stands for model. V stands for view. We will talk about that. That is front end. We do front end on Mondays. Join me on Monday at 8:30. Also here on Facebook Live. And we have what we call controllers. Controllers what controllers? Yeah, it's how we expose our API. Now our API, we have endpoints. We have endpoints. Let me run this. See, it might present some issues because I've not started Mongo, but it actually starts, then stops, then starts again. But as it starts, I'll check on Mongo and actually start Mongo. Here it is. I think this is the Mongo version I've been using. And my computer is becoming a bit slow. So let me start the terminal. This is our terminal, and this is where we run Mongo. We have, if it lists everything that is in this bin file, you see we have bison dump. We have we have our interactive shell. If you want to interact with Mongo, we have MongoD. And yeah, for us to run Mongo on Linux, I'm using Linux, so I need to be the root to have the credentials. Then I'll do this. Then I'll copy this. The server, Mongo server, is called MongoD. MongoD stands for Daemon. I talked about Daemon last time, and I will write my password. Then we expect it to start the server. There it is starting. Then the connection, this is the port 27017, something like that. Actually, we have seen our application has connected. You check here, it has told us that it has connected to our application. Java JetBrains is the company that makes our IDE. So we have application running, should be running. Let me see. Yes, this is what I talked about when I said it to start then stop. It started, then discovered that we don't have a connection to Mongo, an open socket to Mongo. Then it stopped, and then started again. This is it, and yeah, our application is running. I said we are using Neti, that's our web server, and Neti running on port 8081. That's localhost. Then port 8081. We have our endpoints. We looked at our endpoints, which is coffee. So when you come to your browser, we come here. We say localhost. Then we say, what did he say? 81, 81, yeah, 8180. This localhost. Localhost is an IP for local machine. So actually, localhost is IP 127.0.0.1. Then it will have this 8180 and coffee. This is the endpoint. If I change this to something else, let's say our Mac, I don't know for what reasons, and I restart this application, you can have in Spring. You can have you can't run the application like we do in JavaScript, doing hot reloading. So you have to run it again, and then if we come here and check coffee, we won't have anything. But if we come here and say mark, it will have, so this is the endpoints. We have endpoints in our, we have our endpoints here. Not one, not two, not, we have actually 4 of them. We have our, let me take, just go back to what it was. It was coffees, and then let me restart it to run. Okay, I want to restart. I'll explain what I did. This is a get mapping. In HTTP, there are what we call verbs. We have quite a number. I think there are 5 or more. We have what we call get. Get gets data to you. When you want data to be displayed to you, you use get. We have what we call, we have get, we have a post. We have post is for posting data to the database or where your application. We have put is for updating, and we have delete mapping for, we have delete for deleting. For here you see it's called put mapping, delete mapping, and we have another one called patch, but I won't be using patch today. For actually, I made a mistake last time. This, when you do this, you need to add a request body. Request body. I'm saying for even here, I need my request body. I'll be explaining what I'm doing here. So I have my coffee. This is the model of coffee. And then I have what I call repo. And thanks to my friend Daniel Oching. Daniel Oching reminded me this is the interface, this repository comes from what we call DDD, domain-driven design, which emphasizes that the nature of the code we write should be more like the domain, and the domain the domain of the problem. Let's say, for example, we are doing coffee. It should be close to coffee. The way coffee, we talk about coffee in a coffee shop. For day to day, I do insurance, so the domain is insurance, so it should be more of like what we do in insurance. This comes from, you can read the book. Actually have, I'll be recommending that book for you. It's called DDD, Triple D, Domain-Driven Design. I think you can see an image here. I don't know, my internet is a bit slow today. So I'm not seeing the book. The cover of the book, DDD book. Yeah, here it is. It's taken from this by Eric Evans, and it's tackling complexity in the heart of the software. It's a quite good book. It's language agnostic. You can use the patterns in any of your language. Actually, here I'm using Java, and you can see what I'm talking about today can be used in quite a number of other languages. So here we have our coffee, we have our repo. Then we wrote our, this repo, it's an interface. It gives us some abstract methods. Interface gives abstract methods up to Java 7. If you did Java 7, that's what we used to say. But right now we have from Java 8, right now we're in Java 13, and Java 14 is dropping in the next 2 months. We talk, an interface can be what we call functional interface. Like in Java, we have 4 basic interfaces that are functional. We have supply, we have consumer, we have, I don't remember the other 2, but if I remember, I will say there are 4 of them. So we have interface coffee. It extends, an interface extends an interface. A class implements an interface. A class extends a class. That's one thing I didn't get when I started coding. That when you, let's say we do a class, let's say coffee, uh, coffee, whatever coffee mug. Let me just call it coffee mug. And it's a mistake. Classes always start with capital letter. And if I want to extend a class, I usually you extend, then you say another class. Let's say we had class coffee, so it extends coffee. That's how a class extends a class. But if you check on interfaces, let's say we have interface. Interface what? Coffee shop. I'm just giving some dumb ideas here. Okay. Let me see. Interface extends an interface. That's what I've done here. But a class, let me write. We have a class coffee shop. It implements. This is a difference. A class can implement. Let's say reactive Mongo, because reactive Mongo is an interface, it can implement. So when you have a class, you implement an interface. When you have a class, you extend another class. Yeah? And for interfaces, you can actually get several of them. You can have a class implement 2 or 3 interfaces. So this one not what I wanted to talk. I wanted to talk about reactive Mongo is repository comes with quite a number of functions. Let me call them functions, methods. These like methods to save to Mongo, a method to get from Mongo, a method to count the entries we have in Mongo, and yes, and when using Spring, this is a basic. This is always the same for. Let's say we change our database to Postgre. This will be a reactive CRUD repository. When you change we change our database to Cassandra, it will be a reactive Cassandra repository, and we give our object, we give a model. This what we say. This what interacts. The repo interacts with the database. So we have that, and we have this integer. For integer, it has to be. If it was a string, string is an object. String is object by nature, but because integer is not, if you check here, integer here is primitive, with what we call primitives. It starts with the lowercase I, and that we need to, I will be explaining in the future what we call out-of-boxing and boxing and out-of-boxing and all of that. But soon we get rid of this. We have integers starting with integers capital. This is, I think, it's inspired from language like Scala that treat every integers. They are just integers. We don't have primitives. We have referential types only. So in Java there is a project that is bringing integers as these. There are benefits to that. I'll talk about them in the near future. So we have a controller. Last time I did have this. This is what I forgot, and also thanks to Daniel. He's the one who wrote to me and told me that's what I forgot. What I did last time, I had a constructor, and since this is also boilerplate code, you do it every time. You have to have a constructor when you are doing. You have class that is coffee controller, and we are adding it to our Spring application. So we need a constructor. This is boilerplate code. So we need to get rid of that. Before I do that, let me explain. We are we are bringing in our coffee repository. This coffee repository is what we had here. We are bringing it in to our controller so we can get access. This we have, you see, is coffee repository, and the name we have given is coffee repository. It comes with find all. Find all is to give us all the coffees we have in our database. We have repo this save. This will save this coffee. This will be a JSON object for Spring. It does for you, and then what we call serialization. So it will take your data as JSON, post it to database, and when you get it back from in here, it will also be a JSON. So you don't need to do that. Spring does it for you. And so it will save. Here we have save. This is another benefit Spring gives us. It gives us a way that if you don't need to have a different way of saving, for updating, if you have the same coffee with the same ID, you save it. When it looks at a database and checks and sees there's another entry with the same ID, so we need to update. And that as it says, it updates and says we want to say the ID is the coffee is updated. Then we have delete. It comes with delete by ID and the other functions. If I was to delete this and check on these methods, we have delete all. If I want to delete everything, we can have all these save, and we can count. If you want to have a count of what we have, we can use exist. We can use all these functions brought in by this reactive Mongo to our repo. So this is what we did last time. I've taken quite some time explaining what we did. And so today I'm going to talk about, let me create another project. I'm not going to go that way. I'll be more on languages than the framework and what the framework does. So today I'm going to explain what we call the new way, not necessarily new, but what becoming mainstream in programming. We have seen the rise of what we call functional programming languages. This much influence from back in the day. We had Scheme, but today we have the most prevalent language that is functional. We call it Haskell or Haskell, depending on how you pronounce it. This language brought in some changes to what we had. This a pure functional language. Function means that it's purposely focused on functions. It's not object-oriented. It would, even if you hear Haskell people talking about classes, they are not talking about object-oriented classes as we know them. They have what we call type classes, and they're totally different. We talk about that in the near future. So we have Haskell, which is a pure functional language, and then there came a language. We call it, actually my favorite language, we call it Scala. Scala came and brought an idea that we can fuse two paradigms, what we call functional programming, like we do it in Haskell, and what we call object-oriented programming, as we do in normal Java, the Java before Java 8, and we do it in Python, we do it in all other languages, and we can create one cohesive language that offers the two, and Scala does that quite well. And so after some time, Other languages like Java started adopting it. In 2014, we saw the launch of Java 8, which added what we call lambda functions. That's passing a function inside a function. I'll be doing that in the next few minutes. Uh, Also, we saw even C Sharp. C Sharp is a .NET language, runs on Microsoft.NET platform. So we saw it change. It added lambdas, it added functional ideas like lazy evaluation. But since I don't want to talk too much, let me go and create a project. Let me just call it functional. Functional. Hmm, it's supposed to create. Actually, I don't intend to go back here. And yeah, so we'll have a new Java class. We have a Java class. Let's call it what? Let's say, call it functional code. I'm just demonstrating functional code. You can call it good ideas. Let me just call it good ideas. Good ideas. So we have this class, then we have to have our main, which is public static. This is how you write your main in Java. Public static void main, and then we have string, and then that, and args. So you see it give us this. So we actually be using just this one method. What these are? If you check, public is the scope of a package. Static means that this is bound to this class. Void means a return type. A return type, we don't intend to return anything to user to when you execute this, and it takes parameters. You can call them arguments. We used to say arguments, but nowadays we just say parameters. Parameters a string. So we have string, and let me just create a list of integers, and we call these ints. Then we just create them as arrays dot s list. We have 1 and 2, 5, 9, let's say 70, 20, what, 38. They are comma separated, so that's why they are showing an error. And let me import this class. Yeah, we have our list, our lists of integers. If you check quite well, I intended to talk about this because most of the time when you learn programming, you don't get to learn. You don't get to learn about the standard library. Let's say standard library. And here it is. If you talk about the Java standard library, and we view the images. Okay, we have Java, we have what we call list. So we go ahead. If you are to sort this list in some way, in the imperative way of doing things, we will come here and we say, we start by saying, we start with have our initial, let's say, count, let's say integer, then we say, let's say just call it count. And then we are starting from 0. Then the other thing we do, we maybe use a for loop, and then we create actually let me get rid of this and just write a for loop, and we say int I is equals 0. Then we go to a condition that, let's say, I is I think it's greater than or whatever 5, and then we do this is this not this okay, it's like that. Then we go here and then we say I plus plus. Then we have a function. Then we maybe we print. I will do system dot out dot println. Then we print I, not 1. So we have this system system. We have this. It will iterate. It will go from one element to another, from one of our values and check that meets this condition. Then it will increment maybe our count. This we are telling our application, not just we are telling our code, not just what to do, but you're telling it how to do it. Just go from one element to another, to the next, and this is not. This brings way too many. We can have, let's say, if we had like a variable here, and we say count, and we say 0. When we introduce these variables, they actually bring. There are so many ways that we can go wrong when you have variables and incrementing them. So if we can get away of not telling our program on how to do things. We just tell it what to do, and this is what functional programming brings to us. We be telling our code what to do, not how to do it. So we want to be using loops. We want to be using what we call for loop. There is while, do while, or those. Those they belong to what we call imperative programming. Imperative, you have to tell the code, the program, what you are doing. So here we have a list of integers, and it's an array is a list. Then we say ints. Then for us to do, we need to, I'm changing it to stream so we can have a way to do so many stuff. And if let me go. If we wanted to do iteration in a functional way of iterating the data we had, we would have written integer stream dot range. Then we give a range integer. Is that how we int stream? Yeah, it's int stream, not integer stream. Int stream. Then yes, int stream. Then we give it the first value. This why to start. Then 5. Or you can give it in a number. We had 0 to 5. Then we can say then dot for each element between 0 and 5, we want to print it. Let's say a system dot out, and then we print it, print line. This will go through all the elements from the iterator, from one to another, from 0 to 1 to all those. If we want to, we can have another kind which is called in range closed, range closed, which actually doesn't include 5. I think I'm right there. It doesn't include 5. But this is exactly the same way we were doing with for loop. For here, we are using a functional way of doing it. But I am not intending to iterate through this, so I'll get rid of that and actually use this. This is what we have here. And in integers here, we want to maybe get any number that are even, or get integers that are even, or get integers that's for few certain condition. So we turn this into a stream. In Java, you have to say it's a stream, but in other languages, it's not a must. Like in Scala, you don't have to say it's a stream, but here we have to turn this. List is an when I'm talking about the standard library. It has what we call iterables. Iterables, we have sets, we have lists, we have all those. Below iterable is higher than those. Then we have below it, so we need to turn this list into a stream. A stream is a different structure, a different construct. So we turn this and it will become a stream. A stream is more like, for a list is it's like a container that will contain all these elements, our elements. But a stream is, let's say it's like a pipe that things pass through. It's not something, it's not like a container. We are passing our elements inside this stream. So we have a condition. We say, let's say E. Then we have this, what we call lambda expressions. E, we say greater than 5. Then I think, and then we can say for each, then do system. These are print. We want to print out system.out. Then we do print line. We can do this and it will print for us. Let me run it and see. What do you give? Yeah, we have all the numbers that are below 5. Less than 5, we have 1 and 3. Let's say we wanted everything that's below 38. We can come here and say 38, and we run this. This is where the results are coming in. So we check, we see as they change. We have everything that is between 1 and 38. We have 1, 3, 6, 9. We have 20. We have 20 because it doesn't include 38. If we wanted to include 38, we would have done that. Let's see. Yes, it will include 38. So this, you see, this is not, we are not iterating. We are just saying we are using a function filter. These are it's inbuilt in stream this stream in Java, from Java 8 to Java 9, Java 10, Java 11, 12, 13, and even the coming versions of Java. And here we said we have this, we have an element. These are arbitrary. You can use whatever you want, and we use these are called a lambda function. before you used to have a method outside, you have like mini methods, then working them together. But here we are giving a method, a function that doesn't have a name and it's inside another function. So this is what we call lambda expression. In JavaScript, they are called arrow functions. So these lambda functions, you pass it to here, and then we can have quite a number of them. Let's say we can have, if we want just the first, I think first three, we can limit first two, first three, and then we say, let's take the first two and run it. The first two that they fulfill this condition, and they are between 1 and 38, but the first two, so it's 1 and 3, we limit to 2 to that. We can limit to 4, whatever the value we want, and 4 of them. You keep checking here. This is where our output is. So we have that 4. We can come here and let me comment this out. And we can have what we call skip. Skip is exactly opposite of what we have here. Instead of getting us the first 2 or first 3 or first 4, it will skip the number we give it. Let's say if you want to skip 2, it will first skip the first 2, then give us a result. So you see, it skips 1 and 3 and give us from 6, 9, all this. If you check this, we what we are doing here, we are not telling our application on how to go about it. We are just saying we want to skip this. We are not telling it's the duty of our code, of our language, to go and know how to go about it. We're just saying, do this. This is what we want to skip to. We want to limit to first 4, and we want to anything that is below this. We can have many other. We have map. Let's say when we get these numbers, we want them all to find the squares of this. What we say, we can use, I don't remember if you can use E, and let's say multiply by 2. So we'll have this. We see we skipped the first 2, so we started here, and since we don't have 70 70 doesn't meet the first condition, it's out, and we skipped 2, we don't have that, so the rest of the numbers and everything, you have 6, 9, and 20, then we say we want to find the square of this. So we'll come here, and when we run our application, it will give us the numbers. We had 6, now it has been doubled to 12. We had 9 here, and we had 40 for 20. So this is what we call functional programming. And if you check, you might ask, what if we didn't have this for each? Actually, the whole of this sequence of functions wouldn't have been executed, because what we use here is called lazy evaluation. Lazy means it's like, sometimes I feel it's like you tell someone to do something, and then they tell you, I'll do. Then let's say you tell someone to go and get some shopping. They say, I'll do, but they never do it. And you tell them, on top of that, you tell them go and cook, and they don't cook until you go incrementing on what you want. We tell them to filter, they don't filter. We tell them to skip, they don't skip. We tell them to map, they don't map, until we have something that to make them do it. And this is like we, let's say it's our sibling, our kids siblings, and we tell them, if you don't do this, I'm going to beat you up. And then they say, that's when they go to do the shopping, they go do all this stuff. And then just because of the last command we gave them, that we told them, if you don't do this, we will beat you up. So this is what we have. We have this. This will be lazy. It won't do anything until this for each, and we have quite a number of them. This for each is called a terminal functions. It's what to activate this. Everything here is lazy until we get here. Nothing will be executed until we get here. So that brings a lot of why we use lazy evaluation is because we when we are executing programs, we use RAM, we use disk, and quite memory, let's say cache, like a 3 cache. And when we have a nigger, like we tell filter to filter, and then goes filtering without without waiting it to be using these resources. So we want until there is terminal functions, that's when we execute our code. So this filter, skip, this actually, if you check this one, they give you very simple way of thinking through things. You have a list of integers, you turn them into streams. This is the name int. You turn them into stream, then you filter the ones that meet a certain condition, and then you skip, then you do this. You can have as many functions here. You can come and say drop while, you give your condition that you want to drop while. You can say take while. You can have as many functions. You take this and you pass them through all the conditions you want to pass to get you the answer you want to get. The other beautiful thing about this, actually, if you see this, we can have what we call a method reference. I used method reference here. This is a method reference. I used system.out.println, but I used this what I call them, double columns. They are called method reference. We can use one. We can come outside here and actually write a method, a public, let's say static, and then we say it return a value which is an integer, and then we say double. We want to double integers, and then it does the doubling. It say return. It takes int a, and then return, and does the doubling. How do you do double? I think we say a, then by 2, then we do that. So if, let me take, okay, let's stay there. So if we want to use this here, it's quite simple. We'll come here and we just do a method reference. We have our class good idea, so we come good ideas and do a method reference to this. So you can have this, an elegant way of doing this. So we have a map and we have a double int. We're doubling our integers. So we double our integers and we map it here. So let's see how it runs. Yeah, it should give us exact answer as we did, because we are now taking the function outside and we are referencing, we are taking the method outside and we are referencing. So this is what I wanted to talk about. I'll be talking about this in with, let's say I was having coffee here. you can use this after you get repo here. This is updating. Let's see. Okay, let me go back. Let's say after you get here, you don't want to get, after you find all, you don't want just to get that, you want to apply some changes to, you get a whole data, but you want to maybe filter. I don't remember if there is filter. Oh, actually there is filter. Then you give it a filter condition. Then you can say, let's say skip. Then you give it a condition, exactly what you are doing on the other part. We can do something. Then when you're done, we can present the data as the way we want. So this becomes a very useful, elegant way of doing data, and actually gives you a simpler way of thinking through data. Functional programming presents so many other ideas. We have like idea like carrying, where you have a function that has two parameters, two different list of parameters, like if I can show here down here, let's say we have public. Carrying in Java is done in a different way, but I want to say int, and then I have, let's see, get. Let's just say call it get. Then it might have that, and might have another, like it has double this. For this, we give the first parameter, and then when we're running it, we give the first parameter, and it expects another parameter. In languages like Scala, you can put this in implicit, but in Java, carrying is done in a different way. I won't be doing that. And yeah, this actually simplifies way we write code and makes it easier to think through. You can check functional. Actually, wrote some time back. I wrote, if you come to Medium, and then my name, I actually have quite a number of articles, and I wrote what we call functional programming, and then some. Let me see where it is. Reactive programming. Yes, I have such article. There were two of them. I don't remember if I read. Oh, this why functional programming. Why functional programming, and yeah, I wrote quite a number of it. What we target, it explains, we want to get rid of complexity, that our code will be simple to think through, simple to maintain, simple to change, refactor when there is need for refactoring, and yeah, it gives you a good mental model. And yeah, you can see if you read this, it starts this what we are doing. We start with a variable, then we iterate using this the imperative way, and then I talked about functional programming, and in the second article, I went ahead to explain what these are, and yeah, actually even talked about processors and how they do their stuff. And next time I'll be talking about threading and multi-threading and how to go about it with a new model. Like today we run our applications in many cores. Like example, this laptop I'm using here, it has 4 cores and it has 8 CPU threads. And for you to make use of this, that they are not blocked, that application doesn't like stop, it doesn't stop anywhere. We have to make use of what we call concurrency. That application, if application is not executing something, it doesn't use the CPU thread. It releases another function takes over the CPU thread. So you can read a lot of that. I've talked about easier reasoning here, functional programming. This is actually exactly what we are doing, and this is what we'll be doing in the future. For this part, I've used for these articles, I used Scala. Like this is a Scala for a function that takes x, which is an integer. I talked about integers, referential types in Scala. Then this in Java we did a hyphen and this the arrow, but in Scala is more like JavaScript. It has this fat arrow, and then we say x plus 1. We are just adding 1 to our linear. It makes code easier to test. It eliminates what we call we'll be talking about side effects. Side effects is, and one function should be doing just exactly one thing. For example, we wrote a pure function here. The function that I wrote actually got, why is it the recent, then functional. The function here, where if you check this function, this a pure function. It just does one thing, and it doesn't handle, let's say, errors. It doesn't do anything apart from just doing one thing, and that's one thing. If we give this any value, every time we give it 3, it will give us 6. Whatever the thing is, it always give us 6. If we give it 9, it will always give us 18. So it just does one thing, and there is no other thing that we are doing. We usually do like most of side effects, like we do error handling, we do what, like our functions do the things, not the main function they are supposed to be doing. So we'll be talking about functional programming and how it makes work easier. This is exactly what most languages nowadays are doing. We have Kotlin is doing this, bringing some. Kotlin is bringing some functional programming ideas to the mainstream. Scala did it. We have Elixir. Elixir is big on concurrency, how it does concurrency. It has what we call processes, and then processes like minute microservices. So it has processes, it spawns some process and does that, and has a function. It uses some functional constructs like IO monad. Yeah, I said monad, IO monad, and it does quite a number of good things. So we'll be talking about functional programming, and yeah, I hope one day I'll get to the code I actually posted today online. Where is it? This is a code using cats. There's a way. So I'll be explaining this. I'll be explaining this code in Scala. It's using what and Scala cats library, which is a functional programming library, which is quite deep. It has quite good way of making sure we don't have accidental complexity. For example, I can give this example. This simple example, which I'm saying, and trait in Scala is exactly the same as interface in Java, and we call it option, and then it takes a type. We don't specify it. This is exactly the same as Java generics. We specify this when we be using it. So we say we have trait that, and we have some, and we have none. This is an example. This option is exactly the same as optional, that is in Java, from Java 8, and it was made quite good in Java 9. So this is most of the time when you are programming with Java and C# and most mainstream languages, you have what we call null pointer exception. Null pointer is when we have a pointer in memory that is pointing to nothing, none. So when we don't have something, we have none, and when we have something, we have some. So these the two cases of how our option we do. So we are trying to take a side effect that our function, our method can return a null value and handle it in a careful way. So we will be doing this. For example, saying, and this a crazy idea I had, that when you go to wedding, there is type food. Obviously, if you're not the bride or the bridegroom, I guess you are like me. You're interested in food and cake, so you have these wedding attendants who bring cake around, and what you need them to do is get you food, but they can either get you food or you can get some food or not get food at all. So instead of we want to get food, but there's cases where food might not be enough for everyone. So we say we get none, and if there's food, we get some. So we'll be talking about functional programming, more and more of it in the future. And yeah, you can start your coding here. Start.spring.io is where we started with Java, and we'll be talking more and more of this. Thanks for joining me, and see you next time.